here we go. Homework for 12th module. I had to put the number first so it show up in my lineup instead of being at the bottom of the list with the M for the module. This is a new idea. It's a challenge, but we can meet this challenge. We're working with sequences and series, and the challenge for this question is they don't tell us what kind of sequence it is. All they tell us is that we have to find the recursive and explicit rule for the sequence. So if I notice, I don't add the same number every time because it's growing by multiples. I look and take 30 divided by 6 and I see my common ratio is 5. So every time I move a term, I take it times 5. So my common ratio was 5. Remember, I need my A. So my initial value is 6. Now here's another sneaky snake on the homework. They don't have it in a table, so we don't know if they start with the first term or the 0 term. So I just read my story here, a recursive rule for this, and right here tells me they started with term number 1. So here's my first term, second term, third term, fourth term. That helps me check to see if I'm entering the right formula for the rule that is needed when n equals 1, when it starts at the first term. So I put my 6 here, and now my next part of the story has to take that common ratio, and here's where I'm not sure. You don't put a little x as far as I know. You just type the function sign, and then here I have to take the term before it and multiply it by 5 in order to get my next term. So the term before 2, I have to subtract 1, so I take my 5 times my first term, and that's 6, and that'll get me my 30. And then if this was 3, 5 times my second term, 30, I get 150. And so I know I have the right rule for when n is larger than 2. So now the explicit rule is a little trickier because we always take the initial value. Okay, and I'm sure about this typing. You just put a parenthesis in, then you take the common ratio. But instead of just to the nth power, since n didn't start at 0, we have to do the n minus 1 power, because I need a 0 power here to make that a factor of 1. Therefore, my first term is 6. So that's why I had to modify that exponent. We did use this a r to the n minus 1. We use that for our geometric series one, but this isn't how they had to do it in our actual lesson for our notes, because the n started with 0 in our notes. So now we've got it. So I just sketched that out to show you. You have seen it before, but you hadn't had to use it in a sequence question. Now you're ready to rock and roll. N matters. So we enter a recursive rule and explicit rule for this sequence. It doesn't look like we're multiplying, so I take the second term minus, or add, what do I add to 6 to get a negative 1? What do I add to a negative 1 to get a negative 8, like that? Or you can take the difference between these two. What's a negative 8 minus a negative 1? I see subtracting 7. So my common difference for this arithmetic sequence is negative 7. Then my initial value is 6. So I got to know if this list starts with n equals 1 or n equals 0. Well, the recursive rule tells the story. A recursive rule for the sequence is when n is 0. So this is 0, 1, 2, 3, etc. So the recursive rule is we start with the first term, and then we take the term before, and we have a subtraction of 7 in this case. No problems with this typing. I think you'll get along just fine with this one. It's just number 1. I'm a little fuzzy on that. multiplication sign. Just don't use one, and then for the explicit rule you can use parentheses. Now if you remember the explicit rule, we take our initial value and then we add our difference times n. Okay, but n is after 0, so n is 0, so that'll work. N is greater than or equal to 0, that's normal. Okay. For number 2, they do want you to simplify it. So I'm going to put my a in, and I have a minus 7n, so my a, is 6. And there's nothing else to simplify. Okay, here, if n is 0, we get a 6. If n is 1, we get a negative 1. So I know we got the right pattern. Here we go. All done for number 2. Okay, now we get to use our formula to find the stated term of the geometric sequence. So we're going to use the explicit rule. F of n is a times r to the n minus 1. We're assuming it starts with 1. They don't tell us. So we assume it's a first term, second term, third term, fourth term. They want us to get to the 9th term. So you can do it the long way and spend extra time, or you can use your formula. A is a negative 3. The common ratio looks like a positive 4. R equals 4. We're multiplying by. And our n is assumed to start at 1. That way the power will be 0 and our initial value starts up at the beginning. Okay, so the 9th term. So the 9th term is a times r to the 9 minus 1 power. So it's a negative 3 times 4 to the 8th power. This is where, yay, calculator. Okay, so I just put in negative 3 times 4 to the 8th power. Write my big bad number. Okay. So I'd enter negative 196,608. Don't have to put in commas, okay? And that is number 3. So it's kind of like, ooh, hesitate. I don't trust myself, but this is how, worked it through. We use this explicit rule to find the 9th term. It's good. Geometric sequence. Initial term times common ratio to the n minus 1 power. Another one. A is 5. R looks like a negative 3. So watch your negatives. So the initial term, the 11th term, is a times r to the 11 minus 1 power. So that is 5 times a negative 3 to the 10th power. Put that in. Parenthesis, negative 3, parenthesis to the 10th power. Whoops. Okay, so we have 295,245. Alrighty. That was a even power, so I know there's no negative. Just in case you don't enter it right in the calculator, remember even powers, negative answer. We've got that. Big numbers. They go back and forth, back and forth. Multiplying by 5, and then raising it, -3, repeat, repeat, repeat. Taking it times a -3, 10 times. Okay, now we're using our series formula. Remember that? Initial value times 1 minus r to the nth power . 1 minus r. Okay. So we start with our initial value of 10. What do I multiply 10 by to get a -50? And we don't know n, do we? This is first term, second term, third term, fourth term, fifth term, n. So then we use our geometric sequence story, where our last term would equal a times r to the n minus 1 power, 390,000, 3,906,250. So I put my a in, my r, I put a hug around it because it's negative, n minus 1, 3906250, divide by 10. So that just knocks that 0 off. So how many times do I take -5 times itself to get 390,625? So experiments, got to be quite a few. I'm going to take a chance and guess it's -5 to the 9th power, maybe? Nope, too much. So I go back, maybe 8th power. Oh, duh, has to be an even power. So my -5 to the n minus 1 is -5 to the 8th power. So I got it. So I don't, not common, like bases, equal exponents. So my n that I'm going to use for my sum formula is 9, because I add 1. There we go. So here we go. 10 times 1 minus -5 to the 9th over 1 minus -5. So depending on how much you want to put into the calculator, you can set up your parenthesis, fraction, 1 minus parenthesis, -5 parenthesis to the 9th. Put it in the bottom. 1 minus a -5 is just 6, so I'm going to be lazy there. Parenthesis, and I have my result. My sum is a positive 3,255,210. Crazy, huh? So you're adding, subtracting, adding, subtracting, adding, subtracting. And that's the math. Gotta trust it. Okay, another one. We don't have the n, so we do have the a. Our r, what are we multiplying by? Looks like a -4. 4 times a -4 is 16, and n is in question. So I take my a times r to the n minus 1 is my last term. So this is 1, 2, 3, 4, 5. We don't know. So substitute my A in. Put in my R. Crazy, huh? Negatives, negatives, negatives. N minus 1 is 16,384. Divide by a negative 1. So that means I'm going to have a positive or a odd power. Negative 4 to the n minus 1 power is going to be a negative 16,384. There we go. So do my math. What do I take a negative 4 to get a negative answer? Happens to be the power of 7. So you can check and see. Go down, parenthesis, negative 4 to the 7th gives me my value I need. Nice to know that. Equal basis means equal exponents. Add 1. So there's my n I need for my summation formula. So S sub n is A, which we had up here as a negative 1, times my ratio of 1 minus R, which is a negative 4, to the n power 8 over 1 minus a negative 4. So calculator, do the mathness. So I take a negative 1 times, it's just going to make the fraction negative. Then I have 1 minus a negative 4 to the 8th. Down at the bottom, it's 1 minus a negative 4, which is 5. Off to the side, 13,107. So this number was negative inside, took it times a negative 1. Make sure I got that right. It's just like measure twice, cut once. For these problems. That's number 6. 3 left. There you go. Have some fun. Oh, yay. Yay, yay, yay. We already know how many there are. 1, 2, 3, 4, 5, 6. We can fudge and just put it in our calculator, or we can have some fun. Or we could use it to check our answer. We can set up our summation formula. Okay. Our n is 6, so we already know that. So it's A, which is 2. Squeeze that in there. Times the ratio of 1 minus R. What do I do to 2 to get 8? To get 32 to 28, 4. N was 6 over 1 minus R. I'm sorry. Yep. We got it. So you got your notes right there with you. Do the mathness. So 2 parenthesis fraction 1 minus. I don't have to use a parenthesis on my 4. Go down, and 1 minus 4 is a negative 3. Parenthesis. I got 2,730. So just a quick one. 2. I hope you can't see. You can see my math here. Okay, if I put in 2 plus 8 plus 32 plus 128 plus 512 plus 2048. That's pretty cool. They end up to be the same value. We know this is a system that works no matter how many terms you have. You're blessed. Okay, here's a fun one. There's adding 6s and subtracting 6s. So you can apply the formula. That'll work. A is 6. R is, looks like they multiplied by a negative 1. But if you put that in the formula, okay, And we don't know how many, so we don't even know what n is. But every couple, when we add them together, we get 0. So we got to figure out if I end up with a plus 6 left over, if every one of these had plus 6 minus 6 plus 6 minus 6, the sum would be just 6, no matter how many there are. Okay, because every one of these pairs would be 0. But if you end up at the end adding 6 more after every pair, then you have 6 for the answer. So we don't even know what n should be. Okay. So that one's a fun one, because the pairs add up to 0. A unique one, interesting one. Okay, this is just a check to see if you remember what an arithmetic sequence is. They call it algebraic sequence. They should say arithmetic. That's okay, whatever. Has a common number that is added or subtracted. And the reason why we knew that they meant to say arithmetic, because geometric is the common number that's multiplied. And you have just finished your Module 12 homework. Hopefully our review will give you more practice using those formulas, and you'll be a master by the time we're done with this module. Thank you.